very light and short. Okay, thank you.
No.
So we are going on storytelling about architecture of an ocean monitor and forecasting system. Okay. At the start of the talk, I told to you that there are three components for a global ocean observation system: in situ and satellite that produce data, and models. And now we will see how they interact. Okay, in situ this morning, so okay, thank you. Now I switch in the public website of Marie Copernicus EU. This is a platform for Copernicus project, European project. So now just a moment that the switch. Okay. So I don't want to bore you, but this is the satellite part of the ocean observation system. We have different type of satellite. True color, chlorophyll, one for surface, sea surface elevation, sea surface temperature, sea surface salinity, and so on. Wave, wind. In my presentation, I leave you the link so you can access to the entire. So just to know, I don't want to be too long. Just to know that there are different satellites, so different product, and in Italy, these products are managed by CNR, ISAC, or ISPRA, or also private company that collect all data and make some specific product. So just to see, so microwave radiometer on the right, you are seeing the parameters that measured from remote sensing, satellite altimeters, scatterometer for wind vector, and CS concentration. The SAR is important for wind. Why is important the wind? Why it's important to use remote sensing to know the wind at 10 meters from the sea surface. From under to reach.
The wind is forming the storms and
Yes.
everything.
Okay.
Yeah, so I'm planning for catastrophes or something like that.
Okay. So early warning.
Yeah.
Sorry? Oxygenation. Maybe. There is another important
Temperature?
wind. Yes.
For the waves.
Much enough. Answer to all.
For the surface waves.
Who generates the wave? Wind. Okay. And then surface current, so Coriolis, Ekman, and so on. So wind is a fundamental parameter to know and to send to the modeler. Okay. CS concentration, the same. CS concentration is important for melting ice that produce. In the North Pole is the ice is sea water. In Antarctic is fresh water. So melting can change the density, and so the circulation, the longer circulation. Other important parameters is chlorophyll content of the seawater. This is another, this is a panoramic or satellite. I don't want to be too long. Okay. Where we can see data. OVL, oceandatalab.com. Ocean Virtual Laboratory. There is a portal you can find easily. It's just to see you what we can do. You can select the product, get as a produced by processing satellite data. So if you want to know the chlorophyll concentration, ocean core, no, chlorophyll, okay, this one. This is a product that derives from a satellite data sampling, okay? So there are a lot of, I don't know, passaggi, cioè, passaggi in inglese, my satellite move, pass away the area, then interpolate, and so there are a lot of algorithms still performing, and the goal is to reach a nice and elevated accuracy of data. Okay. Yes, if you are logged and for a limited period, but I think it is possible.
I Copernicus. Yeah, I was wondering.
It's quite the same products. So Copernicus and ESA are linked together. And not all. You can find. But Copernicus, if you are logged, you can download in SDF format. Okay.
And you have data, even daily data of clothing. I know. The problem is to take the kind of the density file. Just wondering if there is the easiest way to it. Actually, you can, if you use No, I know that. It's. I was just wondering if it was something wrong with my house.
Okay. The last piece of puzzle of the global ocean monitor forecasting model. So we have in situ data, we have satellite data. What do you do with the data? Move all the data in model. The work of model is to do the analysis, so use satellite data and in situ data to perform another run by using in situ data and to tuning the result. And the goal is to have a minor uncertainty, incertezza. Okay. Obviously, nowcast, so the perform the forecast for next days. Obviously, in the last year, there are using a powerful supercomputer and optimization of algorithm, we have a magic result. If we compare the result with the 10 or 20 years ago. They perform this model. Model is a group of equations that represent a physical phenomenon. Obviously, when we use the solver of the different equations, we make some approximation, but it's the same with the sense as we saw this morning. But it's possible, okay. So, okay, Stokes equation that the differential equation that show that all the liquid is must be in equilibrium. So is a window that tends to be in equilibrium. Just in very few words. What are the output variable and take? This is it's possible to have data and download data from Convergibus data portal. So surface state, wave weight, surface temperature, salinity, wind, and so on. Now also nitrate, nutrients, and phosphate, because some in situ observing platform send data to Convergibus. Okay. Just for example, a lot of you, I think that know this kind of visualization. Yesterday the WMS was full. Today is okay. It's possible to click in a point and download export data in text format, also that other variable. How many of you use this data portal? Carmen? Okay. So it's a place where you can download data. So here is the puzzle, in series satellite model. Okay, we have the forecast, but also have a historical data series that you can use for your biological study or what you want, or to characterize the environment that you are studying or in a research project. It's quite easy to use. This is the light form of my ocean. There is also the Pro. I go full viewer, but just to select the the parameter that you are interested to. You can move this also in the past if you use pre-analysis. Okay, just to show to you what you can do with this. Okay. So during the last year, the power of supercomputer, also algorithm very optimized, you can perform this kind of product. This is a USA man that just for joke make this. So you can select. There is the link on the presentation, so you can see a link what you can do with this. It's very powerful, very obviously there is a approximation, but it's possible to have a synoptic of entire law and make in relation a lot of things. Okay. We switch now the presentation. Okay. So satellite models. Okay. Some key concepts. Ocean models in situ satellite observation are the main components of our ocean monitoring and forecasting system. Observational data, satellite and or in situ, can be integrated into numerical models to ensure they are as close to reality as possible. This project is called data assimilation. It's a very important phase of the modeling process. While the observations only represent a portion of the ocean, models complete this missing information with realistic ocean dynamics to provide an overall picture. The picture that I am showing is the result of all these projects. So data, numerical models, theory help us to understanding some phenomena. Because if you don't understand the process also in a micro scale, obviously in global, but also in micro, you can be able to make some prediction. Understanding is not so easy. And all, this is a key concept that I want to transfer to you. None is sufficient by itself. So I am in situ specialist, I know a lot of parameters. Okay, but what do you do with the CTD data? I am a satellite specialist with a pass-through, I get a lot of data. Okay, but you have a lot of space cover, but one per day. I have in situ island inside, so I take data every 10 minutes. Okay, but you are in a fixed station. So all here must be integrated. All the sections have positive or negative aspects. Above all, where are the economists? How does it cost to launch a satellite? My sense is 2,000 euros for chlorophyll. Satellites to measure chlorophyll, I think also billion of euros. Okay, so I'm joking, but theory, observation, and numerical model to discover CW they must be integrated. And none is sufficient by itself. By combining theory and observations, numerical models, we avoid some of the difficulties associated with each approach used separately that just told. Continued refinement of the combined approach are leading to even more precise description of the ocean, sea and coastal area. This is a continuous process to refine, to reach the goal to make the forecast more accurate as possible. Okay. The ultimate goal is to know the ocean well enough to predict the future changes in the environment, including climate change or the response of fishery to overfishing. So, okay, data, numerical models, theory are all necessary to understand the sea. Okay. The combination of theory, observation, and computer models is relatively new. Operational oceanography was born in 1995. So this approach is relatively new. And in the last decade is exploding in an exponential way. Exponential growth in computer power has made available powerful computers capable of simulating important physical processes and ocean dynamics. We saw in the viewer a lot of gyro current before. When I started to my first oceanographic cruise in 1997, some model hypothetically thinking about this gyre. So in 20 years, we can see in our phone the gyre Adriatic Sea. So just 20 years. Okay. Okay, switch lab activity. Now, we close this part. So we complete the puzzle with the in situ satellite model. Now switch to some applied science. So we have a very nice buoy. Okay. This buoy adesso lo facciamo vedere. The name of the buoy is Fano Fortune, derived from Latin name of the Fano city. Some picture of this. Okay. It's located about 2 miles from the Fano harbor. This is the near real-time sea state. Very nice with the sky, bellissimo. Okay, it's just a piece of streaming that recorded the webcam. Okay, now we can switch to data, the position, official logo, and so on. Okay, last data is quite. We can renew. Okay, now is the last data. So there is a synoptic of all parameters that we talked about this morning. So wind velocity and gust, direction, the spanning time is from the last day of the January, but you can change like this, last 3 months. Okay, some statistic. Okay, temperature. This is the cumulative rain stored in the Fano Arzilla station. Air humidity, atmospheric pressure. Okay, solar irradiance. And now, water temperature, water salinity, and oxygen. There is also the calculation of saturation, conductivity and density, pressure also. And the instruments are located at about 2 meters from the sea surface. It's under the buoy. Okay, sound velocity, chlorophyll A concentration. Question from biologists. What is this? Night and day. And then day chlorophyll, yes. The normal daily cycle of phytoplankton. Okay. Satellite is not be able to capture this. Turbidity. Obviously, when there is some resuspension, the turbidity low height. Water current, we installed a single point at 2 meters, so it's just the current in a water. It's not the water profile with the ADCP, because we haven't the money to buy ADCP. So we have 1 point, but it's about the most important phase of the water current in the surface. Some calculation of the vector, of the velocity, and just to close. So we have some spike, but there is the wave 8 and direction, the red You can make a zoom in this part. Okay. The 2 meters of wave 8 max. And this is the period and the zero crossing. So just to make an example of what we are talking about this morning in applied way. This is the point that is 4 kilometers from here, and data are sampled by the sensor, managed by the acquisition system, sent to a land station. There are some scripts that visualize in a website. Okay. So switch. Okay. We prepare also another. Okay. This picture shows the temperature trend starting from November last year and real-time data or data saved in the cell. What you are seeing? Yes, starting from 20 Celsius degree and move until 25 of January at about 8 degrees. What is the green dot trend? It's from the model generated by the Copernicus model. Okay, so the speech show the difference between real data, in situ data, and what is the output of the model, what you are seeing. Where is the fish that sleeps you? What you are seeing? There is some
issues. Things like this longer than.
Yes, so the model overestimates the water temperature. This is one aspect. So when you will use model data, you have to take into account this. But model is not the worst case. There is also another, this one. Okay. For now, can cut off the oxygen. This is the salinity. Red is the measure in situ. Orange is the model output. What's happened at one fish that live in this water? Biologist. What's up? Died? No. I don't know. The main concept that we will see in the next line is that if you are using a model for your biology scope, you for sure you will use the model. But your animal, your bestia, your fish, your resource, marine resource live here. So fish don't live in Marian, live in that environment. So you have to take into account this. When you use you want to do a simulation or trend and so on, you start from that situation. It's just temperature and salinity. Chlorophyll is a better is a better situation because satellite is perfect for chlorophyll 8, but it's not so special for near the coast. Some question?
That decrease in the salinity of the alveoli or why?
I don't know. We have to.
From 28
Okay.
to 26 is.
It could be also a little rain or some local charge. But salinity 26. Okay.
Could be.
Yes, we have to see. I don't know this kind of sex. We have to know technical, weight, and local situation. The model would be very perfect to understand what's happening. Okay? But there is another phenomenon. Okay, now switch to okay. Our in situ researchers are the best research of the world. No, you have to take into account that the model from Copernicus has a grid of 40.2 kilometers square, and for all the world. So we have to take into account also this. No, in situ is always better than model, yes, but we have to take into account that we are using a grid from 40 kilometers square. So our void is located here. I download data from this point. So it's difficult for the model to understand what's happening in a very, very micro scale. It's possible to model to reach the in situ data if you zooming in the domain. So you can use the model in the open sea as boundary condition, and then make a grid very full of points. Every point is a solution of a lot of equation. You have to recalculate all, and then model can reach the in situ data. We made this kind of work in some paper, for example, for the auxiliary river, for a microbiology study. There is a domain of about half kilometers. So model make a grid very with a high density of point, so we can reach the result of the in situ data. It's all clear, or there are some questions? Mark? Perfect. I don't know if we are clear or you understand nothing. No, a professional professor. Okay. So go on. So we try to answer to the question of the talk. Why you serve this here? For the first position is we are construction long time data series. So if you don't know in the past what's happened, we can do nothing. Okay. Also, when you go out to take sample and you bring to you the CTD, okay, you make a photo of the situation, but you don't know nothing of what happened before. So model is perfect for this kind of situation. Second, we observe phenomenon at micro scale. We saw the salinity that go about 26 PSU. But oxygen, what's happened last 10 days? The blue line is the oxygen concentration. What's happened? Just a few days ago. With the blue trend. Up there is the temperature, dot the model, okay. Salinity is about 32 PSU. What's happened at oxygen? On the right, there is the scale of oxygen concentration. What's happened near the extreme of February?
Maybe a long time of white sea without wind or wave that caused a reduction of oxygen.
Oxygen is 10 to 0. And the bloom is not yet defined. We have to study. What's up? Perhaps I have to see the water current. There is an oxy plume that move and go. Is typical also natural phenomena from the Po Delta, the Po River, about 2 or 3 hours, and then. So it's difficult for a research vessel, satellite, a model to know and understand this kind of phenomenon. Okay. Another aspect that when we will send our data to Copernicus platform, EMODNet, and so on, they can do the reanalysis of the model by using our in situ data, in order to improve the accuracy of the model. But for this process, we need valid data. Because now we have artificial intelligence, deep learning, deep, computer science. Okay. The first lesson in computer science was garbage in, garbage out. Garbage in the system is garbage out. So if you take wrong data or not valid data, we will bias the model result. They take into account also this for a new deep learning approach, deep learning algorithm. Ok, questo possiamo saltare, we can skip, but at this link there are a lot of more precise, more official reason to observe the sea. Yes. We know the global change, heat waves above the Atlantic Sea. Last years there was a big mortality of mussels. Some researchers hypothesized that pouring flux trend is negative, and also heat wave. So heat without food. So a lot of mussel die. There are some new species that introduced from that sea. So a change in biodiversity and so on. So it's important to observe this phenomena to understand this kind of climate change. Open discussion. So the talk is finished. I hope that we fix some key concepts that we have to take valid data. We have to use data satellite and model to understand all the The ozone is very important. A question for biologists. Well, I don't know, I don't have a question for economic aspect. Just for economic aspect. One product of the Copernicus is to calculate the best route in order to be or to reach more sustainability and cheaper route. So we know if there is a hurricane on the Atlantic Sea, this product, according to the forecast, can calculate the best route in order to be a cheaper trip. Just an example, one for economic aspects. Other a lot. Biologist is for you, very
An environment that is subjected to major changes nowadays.
Yeah, non è macerare ma in buona. Okay.
Very bad.
It's the interaction. Magic. So, where the fish live is isolated or interact with the environment. It's not sweet because I make a lot of cruises with very big biologists, and they count the, I don't know, penny. Very accurate, but simply it's not used. We don't know nothing where the fish are. Last 10, 30, 50 years come to be. So I want to transfer that fish don't live in isolation. Interact with obviously with the animals. So we have to know the temperature, the salinity, the oxygen, and so on. All the phenomena that can interact with this productivity cycle, reproducibility, and food aspect, and so on. Stop. You can take the train. Where is the guy? If you want, we can discuss some aspect that you want to go deep, but this Friday, I don't know. I know that you are tired, also I. But if you want, we can open a discussion in some way. Do you have some aspect that you want to understand a deep or go deep? It's okay. Perfect.
A question. Faucet is a type of in situ instrument or not in situ?
It's in situ, but è il mobile, non è there's no separation by the platform. So in situ is overall fixed and mobile. So you saw the commercial ship or glider, all possibility. If it's fixed, obviously it is. Professor Stefano, we have just finished. We are open the discussion. There are, if you want to make some estimate some closing remarks now, I've finished the scientific discussion. Some other question? Come.
About the resolution of Copernicus, because you explained an example, the memory was 40 kilometers,
Yes.
but they have lower, smaller resolution.
Yes, but only on the area or I don't know. I use the reanalysis. Is about annual. This kind of product is the reanalysis and forecast. So it's the last period of reanalysis, not 10 years, but just 1 year. Starting from 23 of November, the last year, the analysis. So the analysis and forecast move, but the limit is fixed. So move the analysis and forecast. Okay. So and the grid is 4.2 kilometers square. But I think that there are also more density.
Okay, 4.2 kilometers.
Yeah. It's a big result. It's for all the world.
Yeah, that's good. Okay.
So it's a It's a very, very wonderful result for models. Because if you use it for all, it is a global field about 4 kilometers. This was
No, because we thought that you said 40
no, sorry, 4. 4.2. 4
kilometers of resolution.
kilometers square. As you can see in the map here, this funnel more here, and this is the point that I download to compare with the voice. So it's very close to the cost. There was other questions? Marco.
Yeah, actually, I am.
That's saying good night.
We are speaking about the satellite data, satellite analysis and stuff. There are some of them that are, let's say, not surface data, something in the deep. Maybe I lost it. I don't speak like.
Not for satellite, but satellite is useful to send out models. And models can calculate the video. So you can know the mixed layer, okay, or the sea temperature at bottom, or the water temperature at the bottom, and so on. So it all
something that is like, okay, please stop the picture and put the data. Is that is available, or that we need, let's say, an algorithm or something?
they are free because Italy pay a lot of money to pay a lot of money to upgrade and manage the infrastructure. So they are all free if you don't use it for commercial purpose. Use it for your research studies, there is no problem. Just to register the bill, you can upload the format is necessary effort, so you have to manage the necessary file. But in the last month, they released a package for Python in order to interface, collect, and download Copernicus data. there are obviously well documented, so if you want, you can make your own script to download, you can select the area, or parameter, which kind of product, so the analysis, forecast, and so on. This this product, no. This product is free, and as you can see, you can mix the C-surface stable with the water current. The author is researcher and use public data. There is the author is I don't remember, but Cameron Beccario. Okay. He made a JavaScript filter in order to visualize public data. So it's possible to use and download it. No, there's a price for Gabi, so okay. Okay. Amen. Okay. Mauro, c'è qualche domanda? So we cover all the aspects of in situ, satellite, and modeling the puzzle that compose the global observing systems.
Yeah, but so this guy, this man, did an own way his page using data from another public repositories and making those data available from his own page?
No, you can. Here we can show just one data. You can download nothing, but he uses public data to do this. It's a billionaire man that will take some result.
Could you bring an analysis about the interaction of different environments?
Just visualize and someone to ask you. No.
The square of the resolution of this imagine discussed in your presentation.
Yes, but we saw this is not Copernicus, but is a private, or I don't know if there is a company that make available in USA this kind of visualization. Data you can find Mediterranean data from Copernicus products. So use case or public data that they are CNCC that use a lot of products. I don't know. I don't know. There is Stefano and Mauro. I just want to show you an interesting slide. I hope this one. This one. Here we have the temperature trend of the sea surface at phenomenon center point, and the red dots are the model results. So there is the difference from model and in situ data, a fixed platform. In the top, in the bottom, there is salinity.
Mine is the model. So.
Yes.
And the other are the actual data.
And the blue line is the temperature data measured at about 2 meters under the surface. So just to show a comparison between data model result, and in situ data. Obviously, in situ data is more detailed, more sensible from the environmental change. But we talk about, we have a model with a grid of 4.2 kilometers square, and is calculated for all the world. So it's a fantastic result. But you have to keep in mind that if you use your data for your simulation, for biologists purpose of study, you have to take into account that there is some not so accurate, but you have a trend of the phenomenon. Here, there is the anoxic water mass that we are talking today at lunch. Reach 0 for 1 to about 3 hours, and then rise to the about 5 milliliters. Other question? You're asking something about Malaysia, no? You will see what happened in Malaysia for the new paper.
Mark,
Another curiosity, what are the new tools? They don't want to leave the room. Climatize here for a week.
When Stefano Appel officially sit down, then always have in mind the train and the railway station.
So, no, I mean, we saw a lot of tools, a lot of code that we can use in the CTD and other. There is something new, something, say, novel on that. And just a curiosity, there's something.
I'm waiting, me also now, waiting for real-time fecal sensor. I hope that will arrive soon. This is one of the, because it's difficult. For example, as you talk about this morning, for the CO2 sensor, there was about 10 or 20 years of hard research, and now we are quite the kerosene is nice, okay, but 20 years of research or a lot of them.
It's not so easy to find something new to reply.
Another new research topics that we are approaching in Ancona is the automatic recognition of fish and fauna with the underwater TV by using the RAW or other kind of video by using deep learning approach. We have made some tests with the Turbo Pro synchronized and synchronized with the post-processing. And there is also some script they use OpenCV tools for 3D imaging, intelligence algorithms and so on, in order to recognize and classify the fish after a very big training phase with a lot of picture of the same species in various. This is another is the formics DNA, you know. We are waiting for proper theories to include the glider where you want. And no, it's quite, there is, no, last week, there is a model science in New Orleans. There is the new science, of course, something quite is a consolidation phase. Just below there are some other companies that arrive with a nice grade of currency, and because remember that if we make a spread money for management, we have to cash very data. You're asking something.
My fish is not very.
Also, we have, as you can see, it's not so bad.
I know that it is possible to see the lakes, but I don't know if. In the sea.
Okay, the answer the
It's dark.
the answer is yes, but it depends on area. Or if there are some group that process satellite data. For example, this year, I asked my colleague, I saw if there are some chlorophyll concentration area around the time measured by satellite. There is no problem. There is for the sea, but for the lagoon, no. Around the sea. So the answer is yes, but it depends on area of interest. If some research group have the focus on this study area. So in general, it's possible, depends on areas.
One thing that when you look at different resources, you use different devices to measure, for example, the temperature, and you will get different measure with different uncertainty on the basis of the device that you use. Is the calibration of the instrument enough, or you have to take into account this, the different resources when you model the data and integrate the data from different devices?
I understand well the question. When you share your data, so when you use the data, that's why it's you scan all cells together. And the metadata is you should indicate the grade of currency of the measurement.
Create a model to test the temperature, and if you want to use any of the sources from the temperature measures for different devices, how do you integrate them?
If you have to take a car, which car do you want? I want other. We want to do by twice. So, I think that if you have speaker data, I for sure use this kind of data. But it's also there is other sure. Because you must use the most accurate sense. Okay. But it's also the reference for other temperature set. So there are obviously different sensitivity, different response time, different power, all the characteristics that we saw this morning. And obviously temperature set considered on the best city gate, you have to pay about 8,000 euro. But the carriage is 0.001. If you want to take a temperature measure with the Arduino, you can pay 5 euro. But your carriage is more or less 1 degree. Just a degree.
It's not enough.
It's an economic issue. Yes. So, but you can use your sensor with the lower cards. But you declare, you must declare the accuracy, the precision of that you know from the sensor. So, people that use your data know before the error that is intrinsic with data. Usually in a CF file, in the metadata section, you declare your temporal accuracy is solid accuracy is position, your position system accuracy is 2 meters, 10 meters, 100 meters. So it's different, no? The same for the temperature kind of sense. In some way, you also must declare the date of calibration of sensor. Because if you use a CTP that for 10 years you never calibrated, we saw this morning the sample. It's okay, but there is a big error. Usually, the cigar or also other factory Consigliare advice. Advice, c'è one calibration per year, but is economic. Just to validate CPD, you spend 1 or 2 thousand a year for transport. So, but you take the sense that you are sure there is less accuracy that you can reach for measure. So, if you have to characterize what that can in oceanographic field of view is mandatory to calculate. So, you want to characterize the environmental condition for microbiology study is not mandatory that you reach the 0.001 depth. 0.1 is enough for calcium. So you can take 3% that you can watch the quality. That's the same. That's the fake. So, there's no question, no answer, so you can stop me.
Grazie, grazie a voi stavolta.
Saluto i remoti, ciao.
So I guess we are done. So I wish to thank Pierluigi and all the colleagues that attend this teaching week this year. It was a long week, I guess. I hope you also had some fun around in Fano. Someone told me some stories. I know something. So now you are free, okay, free to go. The next appointment are in fall, from September, depends on the cohort of students. We have several meetings until Christmas, more or less. So be on time with the reports and all the things that you have to do. I also know that some of you are now leaving, going abroad. This depends on the court of students, of course, and where you are now with your PhD program. I remind you one appointment that is not actually for you, but is for your colleagues, the older colleagues, the 36 cycle colleagues. They are going to graduate defense their PhD this year, and the defense for them will be if everything will be okay with their thesis, because you know you need to go to peer review, and then the external reviewer may suggest minor revision, which means that you are admitted to the final defense right away, or if it's a major revision, you are postponed. But let's say that everybody will be okay. So the students 36, which is my wish actually, yeah, because make things more easy for the students and for us also. The exam, the defense is June 21st. So take a note. If you, I suggest you to be part, if you can. It will be here, of course, but it will be also broadcasted online, as you know. So it could be a good training for you. That, of course, you will need to go through the same procedure in the next future. So on behalf of the academic board of our PhD program, I declare closed the 2024 teaching week, and I wish you all the best for your research, and see you in June for the defense of your colleagues, or in fall. Bye-bye.